Hi everyone, welcome to the math spellbook live stream. I'm your host Peter, and we are getting back into learning more about logic in addition to learning a little bit about sets. So hopefully you guys are having a great start to your Tuesday. Once Tuesday is done, you'll be on your way to Wednesday in the middle of the week. But yeah, let's just basically get started. So I did finish the last problems here, so like from 5 to 6 to 9, like on my own. So I think we can move on to the next step, which is conditional and biconditional connectives. So I think what we got is that we have this section. I don't know how many pages it is, so let's see. This section, let's go over here. So I'm trying to figure out what page this is. This is page 12, right? So for 3, we have it at page 19. Okay, so that means there's 7 pages here. So not too bad. So basically I will probably skim through a little. Well, when I say skim, I mean I will read it to myself, because I know it's like pretty, like it will be silent with me, like not chatting with you guys, unless there's something in chat that I will reply to. But I will basically be reading this, making sure. But actually, maybe I should take a look at the problems first, because usually with textbooks, it's probably better to read the problem so you actually know what you're trying to aim for. So let's see, using truth tables show, okay, so applies that equals that. Okay, so it looks like we're actually going to be working with implied and if and only if statements now, and seeing how they relate back to the stuff that we learned in previous. Okay, so we have, I think this one has 17 problems, right? Yeah, this one has 17 problems. So there's a lot more to go through, actually. So, okay. Let's see. Which of the following statements is true or false? The author is a genius. I find it funny that they add that. The author is an idiot. Let's see. Let CW represent a proposition. Okay. Use the proposition to analyze the logical forms of the following. So we have to know about logical forms. Okay. Then determine which of the statements are logically equivalent. Okay. So what else do we have here? It looks like we're comparing a lot of propositional things. Translate each of the following propositional sentences into English sentences. Okay. Oh, okay, so we have the sentences here, so we have to translate this. Okay. Using truth table show, okay, another one of those. Positional, show that is not equivalent, true or false, the negation statement is, okay. What does the last problem say? By chance. Explain why if you receive the response true, then okay. Okay, so it seems like in this portion we're dealing with implied statements and if or only if statements. So, and this is page 17. Okay, so 17 minus 17 minus 12. That should give us 5 pages. Okay. And we only have like almost half a page here, so I think that's pretty good enough. Not too bad for like reading, actually. I think that's like usually how you plan out a textbook mainly. It's just like look over whatever it is that you know what? Because the thing about my tablet is that I have buttons on the left side, and every time when I write, I start up here. So I probably should switch these around. Swap positions. There we go. So that way I can write without any problems on this side. Even though I'm left-handed, I don't like it when my hand like goes over the buttons there. So, okay. So we have the conditional and by conditional. Oops. Hey Jose, how's it going? What's the best part of your day so far, my friend? I don't know how long I'll be streaming today, guys, but hopefully we can get some stuff done. Let's see, many mathematical theorems have the form if P and then Q, or unequivocally P implies Q. Here's one of the important examples that you may have seen in your calculus course. Theorem f is differentiable at point A, then f is continuous at A. Let D be the proposition of, and let C be the proposition that f is continuous. The theorem is expressed that if D, then C. Okay, so a conditional statement. Back to college. Nice. What are you studying again, Jose? It's been a long time since I streamed, so I completely forgot what you're studying. Was it computer science or was it something else? I'm doing all right though. I can't complain. Did the podcast yesterday on my gaming channel. I streamed yesterday a little bit on like math, mainly focused on the logic, this book. So yeah, I can't really say. Oh, just math, okay, cool. I mean, you're probably farther ahead than me when it comes to material, so, you know. Has the form. I probably should write definition here. If P, then Q. The statement P is called the hypothesis. And Q is called the conclusion. Okay. I guess it's supposed to be like reflective of science. What classes are you taking this semester, Jose? Thus, the conditional statement asserts that the truth of the hypothesis implies that the truth of the conclusion. This is such an important idea in mathematics. Okay. I know it sounds like I'm speed reading, but I'm just trying to get through, like, trying to find the details. I don't know, like, if, like, for stream guys, do you appreciate me reading things out loud, or do you guys, like, basically, like, oh, just get to the meat and butter of the whole entire thing? Okay. Conditional connective, okay. Conditional connective. Given a proposition P and Q, the conditional connective, oh, okay, so it's just this symbol. Implies. I knew that already, but it doesn't hurt to write it down. Can be used. This is. Okay, so it can be used for implies or if ... then ... So we do like that. If P, then Q. Oops. Even more graph theory, probability statistics, differential calculus, geometry. Oh, okay. That sounds pretty intense. Okay. Question. At the beginning of the semester course, your teacher tells you if you do your homework, then you will pass. Your teacher, however, didn't say anything about what happens. I know this is talking about just a scenario, but just trying to find like the essence here. Okay, let H stand for the assertion you do your homework. Okay, represents the statements. Okay. Just false. Oh, okay, that's interesting. So if it's implied, then that means if you have, so Okay, so if it's false, it implies that it's false, thereby it's true. That is really interesting. If it's both true, then it's true. If this is true but this is false, then that means it's false. Okay, so because P is the conclusion here. So if it starts off false, then it is true. Okay, so that I might have to get used to, like this logic here. Let's read more in detail about this. On the other hand, on the second pair, the value is T and F. You see that if you did your homework and you failed the course, then your teacher is a liar. Now suppose that you don't do your homework, as in the third or fourth pair. Remember that your teacher didn't tell you what would happen if in this case. Oh, if you don't do your homework, okay. Consequently, you cannot call her a liar. So if you do not do your homework, the conditional statement H implies P must be viewed as being true, whether you pass or not pass the course. Hey, how's it going, Zach? I will give you a shout out on Twitch because we're multi-streaming. If you guys are on Twitch, if you guys are not familiar with Zach, he is another awesome math streamer. Actually, he is a doctor because he's got his PhD. So if you have any math questions or you want to actually explore some interesting mathematical ideas with him, I recommend checking out his channel. He is a really like pro when it comes to math, so at least better than me, I will say that for sure. But what's the best part of your day so far, Zach? Yeah, actually, like, what are you researching, Zach? False can implies anything, yeah. Okay, so I think we can just write this. So if we have H implies P, and we have H and P, and then H implies P. So if this is true here, false, and false. Okay, so that means this is true, this is false, this is true. I know some analysis differential equations, though I do most of my research in mathematics education at the undergrad level. Oh, nice. I did not know that was your research. Actually, if I was a math major, I probably would have done the same thing, actually, because I think mathematical education is needs something that has to be researched and work on more, especially when it comes to proof writing and stuff. I tend to lean applied math over. Yeah, I'm the same, actually. If I was a researcher in mathematics, I would do applied math than pure math, actually. Even though pure math is beautiful in its own right. But unfortunately, I am not you, Zach. I didn't go for a PhD. I am an imposter. There's a lot of papers about how people learn to write proofs. Oh, okay. Maybe you can direct me to some. It'll probably help me on my mathematical journey. Yeah, we're all unique human beings, so I'm glad that I am not walking in your shoes, because I'd rather you shine in your own brilliance. Okay, so I'm guessing, so in my head, because I'm not gonna try to read, I guess, the way they're kind of helping us interpret this, because these two are probably the things that I have to look at, because I think that's probably what people, when they first see this, looks like, that doesn't make sense, or that's kind of weird. So the way I'm thinking about this is that, actually I should separate these, because they're kind of two different chains of thought. So this one, a lie leads to truth. I'm thinking like TV drama scenario, where it's like the hero basically starts with, like, one of the side characters or the villain starts with a lie, but then it leads to a true event that occurs in the story. I'm thinking of something like that. And for this one, a lie leads to an even bigger lie. But it's true in that scenario. So the conclusion is false because the hypothesis is false. Thus, the statement is true. I mean, that's the way I'm thinking of it in my head, because they're both false, but they kind of encapsulate that it's going to be false, so that way it's true. It kind of goes into a big loop-de-loop when you think about it. Okay, that's a conditional. Can be read several ways. Applies only if. Okay. Let's see. Beginners to logic and mathematics often have trouble with item 4. P only if. Okay, it's supposed to be this item. Okay. To avoid this trouble, one should interpret the expression only if as the arrow, and item 5, P is a significant condition for Q. Okay. Can be interpreted as stating that the truth of P is significant to guaranteeing the truth of Q. So in other words, let's think about this scenario where it's like it's false for P, thus leading to the falsehood of P. But therefore, because it leads to a false conclusion, the statement is kind of considered true because it would lead us to a false result. I mean, saying this out loud is probably better to solidify it in my head, because I've gotten so used to or and statements, but I haven't really dealt with implied statements yet. I mean, I haven't really looked into it deeply, like I did with or and statements. I think it took me maybe a good while to get used to or and statements, actually. Item 6. Q is necessary condition for P. Oh, that sounds like something, like if it had like a negative thing where it's like not Q leads to not P, it kind of reminds me of proof by contrapositive. Kinda. Like, because I think, I think that's how it is with proof to counterpositive, because you start with Q first and then you start with the negative of Q, and then that leads to the negative of P. I believe so. If anyone in chat wants to correct me on that, please correct me if I'm completely wrong. Okay. One way to avoid this confusion is to think of the word significant as the arrow, and to think of the word necessary as the backwards arrow. Oh, there's 2 arrows? Huh. Oh, because this is Q. Yeah, that's why. So it's like it leads to Q. Like it implies Q. counterpositive. Okay, okay. I didn't say you typed yes, Zach. Okay. Because I thought I was wrong, and I was like reading. It's like, wait, wasn't that what I just said? It's like, and you said yes. Okay, okay, cool. Okay, so I am remembering that right. Okay. Thank you for confirming that, Zach. But it's actually cool that you're doing like research in mathematical education. Like, part of me is like thinking back, right? It's like we learn like arithmetic in elementary school, and then once we get into middle school, it's like we learn like algebra and geometry, and I mean hopefully algebra 2 if it's possible. But in high school, I feel as if like wouldn't be a good place to learn pre-calc and like calculus, but then we don't do that. But I guess like a lot of people that don't like math, they don't want to feel like they're behind. So I guess they just, that's why they reteach like algebra and geometry in high school again. Because I felt like I went through like that type of math twice when I was in school. Research is used very loosely. Oh, okay. I see. Oh, here we go. Yeah, I was just talking about that. Let's see. Over here. Our next 3 logic laws. Okay, so these are the logic laws. Was there another pair of logic laws? Okay, no. Okay, cool. So these are the logic laws. The first law states. Okay, so logic, conditional laws. P implies Q. If actually, what's the difference between this and this? Is there a difference? Now that question's in my head. Okay, that's 1, 2. P implies Q. Oops. It's usually if and only if. Okay. Then what about this one? Like the regular line arrow, like double arrow. Is that the same? They're both the same, right? Because I was thinking like, are they both the same or are they both different? Is a number line. Fair enough, because no, in this book they actually use this symbol to kind of identify if and only if statements. That's why I asked. Okay, P implies Q, if and only if, not P or Q. P implies Q, if and only if P and not Q. Okay. P does not imply Q. If and only if P and not Q. Okay, so both of these result in the same thing. You usually don't see that in logic. Okay, I see. Maybe I'm getting my symbols mixed up. Maybe I probably was looking at this symbol instead of this, and I was mistaking this for this. It's possible. Okay, here we go. Proof of the conditional laws. P and Q. Yeah, it's always great when it's like 2 statements, but when it comes to 3 statements, that's when it gets a little bit annoying, because then you have to keep track of all the T's and the F's, and it's like, oh my gosh. Not P and Q. So then that would be false, false and T, that would be true because it's an or statement. Yeah, so then, yeah, you would be end up like that, yeah. Okay. Since all of the final columns agree, by constructing, oh, they actually were doing a proof here. Okay. Alright, give me a minute, guys. I will be right back. Alright, we're back. Hey Famish, how's it going? What's the best part of your day so far, my friend? Yeah, Zach, I know you weren't on my last stream, but I'm actually trying to do, I'm trying to actually challenge myself now, because one of my Discord friends, his name is jetbundle. He basically laid out a video talking about how there's like think of Mount Everest, and like there's certain camps that you can rest at when you climb the mountain, and the first camp is like at the bottom, and he calls it like logic in sets. According to him, with these 2 books that I'm using, within 2 months you can learn this material. At least that's what he surmises, but I've talked to him like back to back on like my progress on it so far, because I just started, and basically he says that I can take my time with it, but at the same time I'm like, if I can do this in 2 months, I'll be like, let's see if that can happen. I doubt it will happen, but at the same time it's like, I just want to see if I can make at least some progress on understanding more proofs this way. I guess it's just a way to basically just for me to challenge myself, but have fun too. Let's see. That's the reason I decided to go back to... Oh, what did I miss here? That's the reason I decided to go back to intermediate algebra courses, since I feel like I felt like I didn't really challenge myself. But I'm also moving on once I get it. I understand it's boiled in my brain. Yeah, exactly. Because the thing of it is with math with me, I just know bits and pieces, but when it gets to like, I think like deeper material, if it doesn't like engage me enough, then I start to forget it, and I'm like I haven't fully connected with the material at that point. Because like with series, I always like forget it, because it's like I haven't engaged with the material enough, or I haven't applied problems with series or sequences. See exercise 1, okay. So we have another definition, what we just talked about. I'm gonna write it down anyway because I mean, even though I know what counterpositive is, I feel like it's good to just rewrite it anyway, so it just solidifies. Because the more I'm exposed to it, the more I probably won't forget it. Counterpositive. Conditional statement. The conditional statement. And actually yesterday was pretty interesting because then Stunky came on and like me and him had like a collab stream. Like he was working on his paper and I was just doing like just textbook work, and we kept each other entertained while we were working. It felt like we were just like in cubicles, like just like talking to each other while working. But of course it's like one of those like times at work where you just enjoy it. It's like, yo, it's like, yeah, about that report. But it was fun, like having Enstunkia on stream together was fun because we were on like Discord and we were chatting to each other, and we were chatting to chat together, which is pretty fun because we always love engaging with you guys. Contrapositive is of a conditional is obtained by first interchanging the hypothesis and the so actually I should write the contrapositive laws because it's a list. Might as well. Because honestly, now that I love math as much as I do now, I end up wondering why wasn't I able to learn proofs when I was in high school or in school at all. But then again, if you were to try to teach proofs to a middle schooler, they probably will be super confused. Because it's like, what am I gonna use this? I mean, at the same time, like, they say that about algebra. Oh, yeah, they're showing how it looks like right here. So I guess with truth tables, you can also make mathematical proofs here. I actually made myself a syllabus to teach myself math. Oh, nice. Okay, we got another definition, the converse. That I have not heard about. Converse. Oh, okay, so if basically you just do if P implies Q, then Q implies P. Okay, that's an interesting one. Whoops. Have lecturers on from YouTube and a textbook. The only thing I'm lacking is my skills in programming, so after finish up my intermediate algebra classes, I'm on one project. Oh, okay, cool. Okay, important note, two statements P and Q, and Q and P implies Q and Q implies P, do not mean the same thing. That is a conditional and its converse, not are not logically equivalent. Okay, this can be shown compared to the final columns of the, okay. Okay. So maybe we should write these these tables, just so that we don't get confused, because I think I probably would fall into that trap. And P, Q, and then Q implies P. Okay, so we have dot 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 dot, then false and false. We'll do it the same way on this side, and then okay, so let's try to figure this out on our own, so that way we can solidify how this works. So if it's true and true, then that means that this whole statement is true. So this is a true statement, but it implies something false, so thereby making this false. This is false, but this leads to something true, so that means it's true. And this is basically false, and it implies something that's false, but in general, it will imply that it's true. Okay? Okay, so the difference on this side is that this is true, but this one is false, and it leads to something true, so that's true. This one is true, but it leads to something that's false, so that means it is false. And this is basically leading to something that's false, but then it leads into something that else is false, so that means it's true. You can also do a lot of programming and math. Oh, okay. Yeah, like, I think with programming, that's the thing where it's kind of like, I have to find like something to actually engage with both math and programming, because with programming, it's not that learning the languages are hard for me. It's just that making a project where I use them, that's the thing that I kind of have an issue with. I can learn the syntax. The problem is that actually using it to build something, that is the thing that I kind of am not very predominantly, how should I say, attemptive to. I try not to be lazy with it, but whenever I try to learn code or anything like that, or like do something on like what do you call those? The command prompts, it just doesn't feel engaging enough for me to actually pull me into the project. Maybe this is why I'm not a programmer. Because I took one C++ course, and I did pass the course. It was just so boring for me, because like I learned the syntax and I basically trained myself to like learn how to type the code and everything like that, but at the same time I was like, why do for me it was like, why does anyone want to program something? To me it just felt boring. But then again, like I don't know, maybe I wasn't engaged with the project. Like a project I really wanted to get done. Could have been that. Let's see, in mathematics it is highly valued when one can prove that a certain concept, say A is equivalent to a seemingly different concept B. The resulting theorem will have A if and only if B. Okay, so A if and only if B. One uses the phrase if and only if to assert that two concepts are equivalent, that is, alternative ways of saying the same thing. We introduce a new logical connective to convey the mathematical meaning. Yeah, this is what I was talking about. Yeah, in this book, they use just the line here. truth table, if we have P, if P, if and only if Q. So now let's do that. If and if, only if Q. Now let's see if we can figure this out on our own first. So so P if and only if Q. So if these both are true, then that means this is true. P is true if and only if B is false. To me, that sounds like something it could be a true statement, because the way if you kind of phrase it out loud. Because then if it's like P is false if and only if Q is true, and P is false if and only if Q is false. Because now I'm trying to think, does it have the same type of pattern as the conditional statement, or do we have to think of it differently in that regard? That's the thing that I'm trying to like think about in my head. Because the way it reads, it seems like it is, yeah, it is biconditional. I mean, it's in the name biconditional, but the thing of it is that for some reason it feels like it's a tautology, but I don't think it's a tautology. I'm trying my best not to look at the table, so that I can basically think of this quote unquote logically, so I can actually engage with the material. Because I mean, as a sentence, it kind of makes sense when you think about it, but what does that say as the sentence as a whole? And I think that's the thing that I'm trying to think about, because it's like, because both like P and Q are supposed to be statements, and those statements have truth values. But the thing of it is that the truth values, the thing is that if Q is false, then that implies that P is true. But if P is true, then that implies that Q is false. Now, the question is that what does that mean for the statement as a whole? What does it say in here? Oh, okay. So basically, I had a feeling that was that kind of relationship. Because I'm like, if these two are different, then it kind of feels like it's kind of like contradicting itself. So if they're ever different truth values, then that means they're going to be false no matter what. Okay, so they have to have the same truth value. Okay. Sounds reasonable enough. And then by conditional laws. Actually, I want to take a quick look on YouTube for a second, because I want to make sure that our stream is like streaming on YouTube. Okay, so we're going live. I think we're going live on both the long form and the short form. Okay, cool. I just wanted to make sure of that. like my brain was like completely like phased out at that point. Okay, so P. The expression if and only if is used. Oh, we have an abbreviation for it. I think I've seen this one too, actually, whenever I like read stuff. Okay, analyze the logical forms of the following statements. The picnic will be canceled if and only if it is either windy or rainy. If the picnic is canceled, then John will watch a movie, and if the picnic is not canceled, then John will not watch a movie. Okay. So analyze the logical form. If and only if it is either rainy or okay. So it's like we have two statements here, whether it's windy or rainy. The picnic will be canceled. First, like now I'm trying to think of it like constructing like a bit of a like a logical like framework like this. Reinstate the laws. Yeah, I think I'll write these twice so that, because I like it when they're all gathered up in one spot. That's the conditional laws. And then the counterpositive laws. Oops. Not contraposition. Counterpositive. Guys like math or physics, or you just want to have someone to have as background noise for whenever you're studying or just working on your own projects on your computer, drop me a follow if you're watching this on Twitch, or if you're watching this on YouTube Shorts or YouTube Live. Hit the sub button and leave a like on the video. in addition to leave a comment down below. We also have a link in the description on our Discord server. And if you're on Twitch, you can type in !Discord and it should lead you to our Discord server. Okay, show that. Let's have fun with this one. Let's actually try something, because we haven't done any problems yet, so... I mean, we did some, like, truth tables, but I think now let's see if we can engage with the material. Because I think the fun about, like, math books is that they have, like, examples, and sometimes with examples they can, like, kind of, like, make you feel like, oh, can you solve the problem before you read about it in the next part? By using... propositional logic laws. Okay, so I'm going to raise this up a little bit because I don't want to peek at the I don't want to peek at the solution. Yeah, I think we got it there. Okay. Okay, show that P implies R and Q implies R is if and only if P or Q implies R. Okay. Use the logic laws. Okay. Okay. Let's see. We have. Can we? Huh. So we start out with this. And this is supposed to imply, or if and only if, P or Q so I feel like this is something with De Morgan laws, because it feels like it's more De Morgan laws, but usually for De Morgan laws you usually see like a negation. I mean, it kind of feels like that type of scenario. Because you could do the distributive property and like remove these, but then you're left with the problem says, yeah, it has to be an or statement at the end, but this is an and here. So this one is pretty interesting. Yeah, because the way I see it is like you can remove that, and then with that out, then you're left with P and Q. But the thing of it is that where do we get the or statement from? That's the thing that I'm not seeing here. But then again, maybe we should look at what both of these mean individually, because truth table wise, if we look at them as truth tables, maybe that will help us in a way to figure out exactly what we need to do here. Because usually I have a bad habit of not thinking about the problem like well enough, and then I realize that I missed something. So, thinking back to what we thought about this would be true. This would be false. This would be true, and this would be true. And then the same is on this side. So it would be true, false, true, true. And then if we have them both like this, oh whoops, I didn't mean to divide it like that. If we have them like this, parentheses, don't forget the parentheses. If we have both of them, that would be true. And then it's an and statement, so then if it's like they're both false, then that means this is false. And then that's true. And then that would be true. So it means the same thing as now when it comes to this side. So if it's this one, I mean the truth table is going to be the same. It's just that it's for me it's kind of good to like layer it out, because I think I'm trying to think of this deeper. Like maybe I have to find like a deeper implication in here to basically think of how this can actually make sense when it comes to the or statement here. P and Q, so if they're both true, then that's true, which implies that R yeah, then it'll be like a third version of it. Yeah, that's yeah, it's just one little thing that is like, but then again, that's usually how challenging math problems kind of like, I just don't want to write the truth table for this thing, because that would be too cumbersome actually, because I have to worry about three statements instead of two, which I don't want to do. I don't want to fixate on that. let's look at the look at these. Maybe we'll find the ability to like contemplate here, because maybe, oh, okay, I think I'm starting to see something here. Oh, hello, Rushback. What's the best part of your day so far? Oh, okay, maybe this could help us. Like one of these, actually. Oh, wait, hold on. Oh, this is biconditional. So, wait a minute. I think I see something. So we have this. It can turn into this. Because now I'm trying to think of all the other operations. That my 2 analysis exams are through now. Nice. Congratulations. How'd you think you did on them? Yeah, I think like after this, like after I try to figure this out, I'm probably gonna end stream because like my timing is like really not like really like going in and out of different things. I will say that for sure. Because I got a message from someone and I feel like I have to reply to them like pretty soon. On the first good one, the second one not so good. Oh, I'm sorry to hear that. I mean, how many exams do you have for the class in total? If you have like a lot of exams, then you'll have more chance to boost your grade. If it's like 4 exams, then basically it's like the first one, yeah, like you got like a good start. Now you just basically have to make sure the 3rd exam you don't do like you don't do as bad as the 2nd one. And then on the 4th you practically just have to make sure you like at least do well on that one. Like you have to do well on the next 2 if there was like 4 exams. I know where we can remove the R, it's just that getting the or statement, that is the thing that I'm trying to figure out. Maybe this one will help us because it has an or statement in it. So if P implies R, then that would mean that not P or R, and so this one is the conditional laws. So not Q or R. So, this is the conditional laws. It's the only exam and the final exam. It's a module exam, but I think it might be able to pass it by a small margin. Oh, okay. Well, hopefully that is true. Okay. So now we can do the distribute, because I think we got to get the R out of there. So I'm trying to figure out how do we do this, because I think it would be like P and not Q, and it would be or R. Okay, so that would be the distributive law. I think let's see. Feels like we're getting close. It's just that I have to figure out how this works. Let me see. I guess I'll leave this as an exercise for myself later, because my brain is like going in and out of like distractions. Sorry. I mean, it happens sometimes, guys. But at least we managed to cover most of this, because like I think, yeah, the exercises are like next up. So hopefully when my brain is clearer out, I'll be able to like do this like later on in the day. But thanks for joining me today, guys. I know this was kind of short, but you know, sometimes the brain wants to like focus, and sometimes the brain gets like easily distracted, and you know, I am not guilty of either of those things, of both. So yeah, but thank you for joining me today, guys. If you're watching this on YouTube or YouTube Shorts, you know, drop a sub if you like math or physics and just need a little study stream to keep your guys occupied. If you're watching this on Twitch, you know, drop me a follow. Always appreciate it. In addition, if you want to join our Discord server on YouTube, there should be a link down in the description below, or on the side, because YouTube Shorts. If you're on Twitch, you know, you can type in !Discord, and it should give you a link to our Discord server there. And yeah, that will do it for today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So take care, guys. Bye-bye.